In today's hardware session, we're going to cover storage, cooling, and different expansion cards that come with your PC or laptop. We're kicking off day 2 of hardware with cooling. Computer cooling is essential because as your computer works, your CPU, different components that are connected to your motherboard can overheat. And this overheating can cause long-term damage as well as short-term glitches and things that are happening to your computer that you might not understand at the moment, as far as your computer acting slow or freezing up. Your computer has to operate at a certain temperature to have optimal performance. It's better to keep your computer components in isolated, cool environments. You don't want your computer to be in a hot storage closet running 24/7 because different components of your computer will overheat, like your CPU, like your hard drive, and it will cause extensive damage. So we'll talk about different things that will help your computer last longer as well as perform better. The fan is a common cooling device available in most PCs and laptops, and what the fan does is it rotates. It's pretty self-explanatory. It's a fan. It rotates and it makes sure that computer components are cool within the case, within your computer body, within your PC, or within your laptop. A computer case is used for active cooling. Fans are used to draw cooler air into the case from the outside, expel warm air from inside, and move air across a heat sink to cool a particular component. The heat sink is attached to your fan, and it's the metal part that kind of distributes that warm air outside of your machine. So heat sinks can be applied with multiple components inside the system. Their function is to dissipate the heat from the element that they're fixed to, and commonly used for older CPUs. Heat sinks work conventionally and are attached to those parts that do not generate immense heat. So it's usually like attached to a fan or something, or directly to the motherboard, as you can see in this picture over here to the right. Thermal paste is something that is used on CPUs primarily. The main role of thermal paste is to eliminate air gaps or spaces. So it's basically like insulation. It acts as insulation for your CPU. It maximizes heat transfer and dissipation. Thermal paste is an example of thermal interface material. A liquid cooler, you'll see this in a lot of like gaming PCs. And liquid cooling is basically tubes running in and out of your computer that transfer liquid around hot components of your computer, so hot parts of your computer. So in the next picture here, you'll see these tubes that run along here, and what they do is they basically act as your cooling system. So they'll run water basically over certain components of your computer. It's a combination of an active and a passive cooling system. This form of cooling system is the best out of all of the other cooling systems. It's more efficient. It's a combination of active and passive cooling. An active and passive cooling option exists with both air and water cooling systems. With passive systems, the process of cooling at the radiator is conducted through standard air movement. With the active alternative, a fan is responsible for producing the airstream. Active cooling systems are better than the passive ones in terms of cooling rate, but the passive compensates the same with the lower energy consumption and versatility. Just about choosing the right type for your PC. So it's all about your PC. It's all about your preference. If you want to have a lower energy consumption, a passive option is better for you. If you want to have better performance, then an active option may be better for you, depending on what you're doing. So if you're somebody who is always on your computer and you're doing heavy, intense activities like gaming, computer editing, an active cooling system is definitely going to be for you. Whereas if you're somebody who's just a casual computer user, you really don't care about performance, all you're doing is browsing the web, then a passive cooling system may be okay for what you're trying to get done. So here you can see a picture of the cooling system, the water cooling system. It looks pretty cool with all the lights and the tubes. Expansion cards or add-on cards are used to provide additional functionality. So your network card or your NIC, your video cards, your sound cards, these are all examples of expansion cards. And when you're using these expansion cards, be very cognizant of the models and the different types of cards that you're using. And I won't necessarily go as in depth in this course as I can, but I will link some tapes so you guys can kind of get a little bit more knowledge based on the different parts and components and compatibilities with motherboards, because that is extremely, extremely important when you are going to pick out these cards when you're building your own PC at home. You're going to need to know what compatibility that each of these cards has with each motherboard. So be cognizant of that. And I'm basically just going to give you the overview of what these things are, and you'll be able to make a choice from there and do your own research based off of that if you're building your own PC as you're following along with this course. But as we dive into expansion cards, it just basically increases the functionality of your computer. So you have motherboard, you have fan, CPU. Now we're getting into things that are gonna add sound, video capability so that you can interact with your PC. So video cards, we're gonna hop off with the video card. The video card is an extension card that produces nourishment of yield pictures to a show gadget, such as a computer screen. Most video cards are not restricted to basic show yield. Their coordinated design processor can perform extra preparation, evacuation. This assignment from the central processor of the computer. Video cards can come as an onboard or as an add-on card. So basically, video cards are huge for gaming. They offer different ports for you to connect with. You have the VGA cable, which is kind of a deprecated cable. So these cables to the left, this is obviously an older video expansion card. To the right, you have a newer video card that comes with a HDMI. As you can see, offer you different ports for monitor connectivity. Video cards are very expensive. Another word for a video card is a graphic card, and these control basically the output for your computer monitors. The interface card, or your network card, aka your NIC. Your NIC is your LAN adapter or physical network interface. And basically what this does is this connects you to the internet. So as you can see here, you have an Ethernet port, which is going to connect to your router, and that is ultimately what connects you to the internet. And we'll go deeper into what that really means a little bit later on in the course when we discuss the internet and how it works and the connectivity. But just know that your LAN connection, your local area network connection, is controlled by your NIC, your network card, basically your network interface card. So this is your gateway to the internet. So we're moving along. We've covered cooling and expansion cards. Right now we're going to hop into storage devices. In this module, you learn about the difference between various storage devices, volatile and non-volatile. So volatile versus non-volatile means basically volatile storage is a type of memory that needs power to preserve stored data. So what that means is when you turn the device off, that data essentially is erased. So RAM is a form of a volatile storage. RAM, random access memory. It randomly accesses memory. It's basically your computer's short-term memory, and we'll get into that a little bit later. But RAM is an example of volatile storage. Non-volatile storage would be something like a hard drive or an SSD, which is a solid state drive. And the difference between volatile and non-volatile storage, basically all you need to know is that with non-volatile storage, once the power is shut off, that storage, that memory is still stored on that device. So all your data, all your files, everything is still going to be available on the device, even when the power is off. So that's the main difference between volatile and non-volatile. It is the availability of the data when the device is with or without power. So without power, if your data is lost, random access memory, that is volatile. If the data is still available after you turn it off, then that is non-volatile. That is an example of non-volatile memory. Disk storage, or your hard drive, usually is what people are used to when they talk about storage. A hard drive or a hard disk is a type of data storage that is used in laptops and desktop computers. A hard disk is a non-volatile storage type, which means it can retain the stored data even with no power supplied to the device. It contains one or more platters, and you'll see those platters. They're round and they're shaped like plates. Platters. So when you think platters, think plate. Housed inside of an air-sealed casing, data is written to the platters using a magnetic head, which moves rapidly over them as they spin. Hard drives are available in two types. The two types of hard drives are solid-state drives and spinning disk drives, which use magnetic storage. So a solid-state drive has no moving parts, and a spinning disk drive uses magnetic storage. That's the one with the platter, the arm, the head, all that stuff. And I'll give you a picture of that after this. So spinning disk is the mechanism with a hard disk drive to which memory is written. So that disk, that platter, is where the memory is actually written. Rotating plates attached to an arm that writes the data. The spinning disk mechanism physically resembles a record player. So if you guys have ever seen like the head to a record player that drops down onto the actual record, that's the same way that a hard drive basically works on the inside. Although it's sealed, it's sealed within an enclosure, so obviously you can't see it. The plates are magnetized, similar to cassette tapes, in order to store data that is written using copper heads. Although solid-state drives have become very popular as a startup system drive, they still do not offer the cost per gigabyte or capacity of spinning disk drives. What that means is SSDs in general are more reliable, but you can get more storage for less money, basically, with a spinning disk drive. Spinning disk drives, they have magnetic coatings. They read-write heads are moved to the correct location to read existing data and write new or changed data. So keep this in mind. Since that head is being written on that platter, that head is susceptible to damage. So another advantage to having a solid-state drive is that physical damage is less inclined to destroy your drive. It's way easier to break something with a lot of different little moving parts than it is to break, just a solid device. So that's another upside to having a solid state drive. Hard disk drive, definitely better for your pocket. Solid state drives, better for your peace of mind. A circuit board on the bottom of the drive assembly contains cache memory, the SATA controller chip, and SATA power and data interfaces. So we'll get into SATA a little bit later, the difference between SATA, PATA, ATA, all that stuff. SATA, PATA, ATA. SATA, PATA, ATA. Sound like a Migos song. Typical HDD capacities range from 500 gigabytes to 6 terabytes, but high capacity HDDs for desktops and small servers are now available in capacities as high as 12 terabytes. So when we talk about storage and we talk about gigabytes versus terabytes, gigabytes are 1,000 megabytes and terabytes are 1,000 gigabytes. So they're basically increasing storage levels. And there are other storage capacities, but for the most part, just focus on terabyte, gigabyte, and megabytes. Those are the most important for what we need to do. And here you have a computer hard drive. This is an actual disk right here, so you can see the platters layered on top of each other. You can see the head, the read and write head, and that's what's actually reading and writing the information. The arm is constantly moving, so the arm will move the head around on the platter so it can find the right information. You have your saved files over there, so you can see the arm will have to go over there to read and write. It'll obviously have to spin. Another thing about hard drive speeds is that the faster these disks spin, the faster your hard drive can read and write and download and upload information. So your performance is based off of how fast this disk can spin inside of your hard drive. So keep that in mind. Higher, and they're measured in megabytes per second, so MS. So be cognizant when you're looking for a hard drive. The megabytes per second is going to be how fast your drive can read and write information. And the higher that number means the higher amount of rotations that your platter will do within that second. So the higher the number, the better performance you're going to get out of that hard drive or out of that disk. storage capacity terminology. So we're basically going over what we kind of went over earlier in the storage module. So storage capacity refers to how much disk space one or more storage devices provides. It measures how much data a computer system may contain. For example, a computer with a 500 gigabyte hard drive has a storage capacity of 500 gigabytes. Megabytes per second is a unit of measurement for data transfer speed to and from a computer storage device. So this is the rotation basically of the head and how many megabytes per second that computer can transfer and store and read and write. Now that we've gone over a couple different storage devices, we'll hop into what local storage means and the different storage types. So a hard drive can be part of a local storage system for a computer. Systems now use SSDs for their hard drives, but local storage is the first type of storage available when you turn on a computer, tablet, or your smartphone. Local storage does not require an internet or even a network connection. So local storage is an example of non-volatile storage. When we talk about local storage systems, the one thing that a lot of people always bring up when it comes to performance is your random access memory. So your RAM is like your computer's short-term memory. It helps the computer store and use information quickly while it's working on tasks. RAM is like a desk with lots of sticky notes where the computer can write down and read important things it needs right now. The more RAM a computer has, the more sticky notes it can use, which helps it work faster and can handle more tasks at once. But remember, once the computer is turned off, all the sticky notes on the desk get wiped clean. So it's important to save information on a hard drive or other storage for later. So RAM is a volatile form of storage. To install RAM, there's different types. So the physical component would be used for, so you got to know what physical components are going to be used for RAM for your laptop. The type of physical package that installs into those slots on your motherboard is a DIMM, D-I-M-M. This is a dual inline memory module. It's called a dual inline memory module because this memory module has a series of contacts on one side of this module. When technicians are asked about the computer's memory, they're primarily talking about random access memory. RAM is used for short-term storage of applications or data so that the processor can access and use this information. In contrast, computers use hard drives for long-term storage data. Most volatile is RAM. This doesn't mean that it's explosive, it just means that the data in RAM is lost and power is removed, and we want to keep reiterating that. So if you have something stored on your RAM, it's gone once you lose power. When it comes to RAM installation, you want to take anti-static precautions. So you want to hold your RAM module by its edges and not by the little gold parts that are on the bottom. Like processor, RAM modules are sensitive to static charges and should be handled very carefully. So make sure that you don't have any plastics around, any styrofoam. Those things can shock the RAM and it can destroy your memory. Static in any form or capacity will destroy memory. So just be cognizant of that. Try to make sure whenever you're installing any type of hard drive or any type of storage device that you don't have any static around, like, so no plastics, no styrofoams, nothing like that. Never touch the metal conductors of a memory module and only handle RAM by the edges. So just reiterates, don't touch that little gold part or you're gonna destroy your RAM, because RAM is pretty expensive, and you know, who just got money to just be thrown around? Especially nowadays, inflation is high. So, you know, everybody in this course is trying to get money and keep as much money as they can in their pocket. So, you know, definitely do not mess up a stick of RAM being careless. DDR speeds. So we're gonna hop into DDR, and DDR is basically double data rate memory speeds for your RAM. And imagine you have a magical mailbox where you can send and receive letters really quickly. DDR speeds are like how fast you can send or receive those letters. So let's say you have DDR3 and DDR4, which are two different types of mailboxes. DDR4 is faster than DDR3 because it can send and receive letters at a higher speed. It's like DDR4 can send or receive more letters in the same amount of time compared to DDR3. So if you have a computer with DDR4 memory, which most of them nowadays do, it can transfer information faster, which helps it do things quickly and programs run smoothly. It's like having a super fast mailbox that can handle lots of letters in a short time. Just remember, when you get a new computer or upgrade its memory, it's important to check what type of DDR speed it supports to make sure that you're using the right mailbox for the best performance. So don't just go and get a stick of RAM thinking that it's going to be compatible. Definitely check the compatibility specs for your motherboard. Double data rate memory types. DDR is double data rate memory, and the different double data rate memory types we just went over the different double data rate memory types. Double data rate memory types are a type of RAM technology that allows data to be transferred at a faster rate compared to older memory types. The double data rate means that the memory can send or receive data on both the rising and falling edges of the clock cycle. DDR memory modules are designed to provide higher bandwidth and improved performance compared to previous memory technologies. They achieve this by transferring data twice as fast as a computer's internal clock speed. For example, DDR3 memory operating at a clock speed of 800 megahertz can transfer data at a rate of 1600 megatransfers per second. There are different types of RAM modules, and the different modules are separated by different acronyms. So DIMM, we just went over, dual inline memory module. It has a series of memory chips mounted on a circuit board with pins on both sides. DIMMs are commonly found in desktop computers and servers. SODIMM, or the small outline DIMM, is a smaller version of the DIMM, primarily used in laptops, small form factor computers, and compact devices. That has fewer pins compared to DIMM and is physically smaller in size. DDR, double data rate, is a type of RAM module that refers to the generation or version of the memory technology. For example, DDR and DDR4 are common types. Each generation offers improvements in speed and performance compared to the previous one. And as you can see, this goes into more detail for DDR2, which is older, DDR3, which is popular, and DDR4, which is the latest for our RAM modules. These RAM module types have different physical characteristics and pin configurations, so it's important to ensure compatibility with motherboards and other system requirements when selecting or upgrading RAM modules. Super important. As you can see, there's a consistent theme here. When you get a motherboard and you're building your computer from the ground up, you have to make sure that you are using and ordering parts that are compatible to your motherboard. So pay attention to the specs. It's super important. It's basically the most important thing in building a computer. And you can do some more research on double data rate memory and the types. And now we're going to hop into memory reliability protection. And I've kind of sprinkled this through the course to kind of break up some of the different modules that we have. So we're hopping out of RAM and into memory reliability. So as you know, RAM does not have a lot of memory reliability because after you lose power, there is no more memory to be preserved. Memory reliability protection refers to various techniques and features implemented in computer systems to ensure the integrity and reliability of the data stored in memory. These protections aim to prevent or mitigate errors that can occur due to hardware or software issues, which could potentially lead to data corruption or system instability. So whenever you're working on big projects or you're transferring data, you definitely want to have memory reliability protection, and this includes regular backups, and we'll hop into the different kinds of backups here a little bit later, but definitely be aware of that and keep a mindful eye on how you can protect your memory as you work in organizations and as you work on personal projects yourself. Some common reliability protection mechanisms include error correction code, ECC. This is a feature commonly found in server grade or enterprise level memory modules. It detects and corrects certain type of memory errors such as single bit errors or even multi-bit errors. ECC helps maintain data accuracy and prevent data corruption. Parity checking is a simpler form of ECC used in some older systems. It adds an extra bit to each byte of memory data to check for errors. However, unlike ECC, it can only detect errors but cannot correct them. So ECC can correct errors. Memory scrubbing. Memory scrubbing involves periodically scanning and refreshing the data stored in memory to identify and correct any potential errors. This technique helps maintain the integrity of data over time, especially in systems where errors can accumulate gradually. So it's all about what's best for you. I would recommend ECC or memory scrubbing. Parity checking is obviously a deprecated form of reliability protection, but it is one that you should be aware of, and you should implement at least one of these forms of protection whenever you're working on a project or if you're in an organization. Multimedia cards is a type of tiny memory card standard that is used to store data among different compatible portable devices. People use them to transfer data. As you can see, 32 megabytes, 16 megabytes. It's not a lot of data, but for short, quick exchanges of files. Storage cards, flash memory card, sometimes called a storage card, is a small storage device that uses non-volatile semiconductor memory to store data on portable or remote computing devices. Such data includes text, pictures, audio, and video. In video production, I'll use these cards. These offer you a lot more storage capacity and capabilities. So the compact flash offers 4 gigs. As you can see, the SanDisk offers 2 gigs. All of these offer gigs. So I have some cards that have like 128 gigs. I've had some cards that have 256 gigs. It all just depends on what you want and what you need. For video editing, you need a little bit more. A riser card may be a printed circuit board that picks up a large number of flag lines through a single connector on a motherboard and conveys them through devoted connectors on the card. Riser cards are regularly utilized to permit extension cards or different ports accessible to a framework encased in a low-profile case where the stature of the case does not permit the opposite situation of a full-height extension card. In this picture here, this PCI slot has been converted with a riser card into a slot with 2 other PCI Express slots. So that's basically what that is there. As you can see, you can probably start recognizing the parts of the computer now that we've gone through them. So you can see a riser card right here. You can see where your CPU will sit right here. You can see your actual heat sink. They have a pretty big heat sink right there. So you can kind of start identifying pieces of a computer now through looking at it. I'm not saying you're going to get it the first time, but once you get more familiar with it, you'll become a pro. We already went over magnetic disks, but this is a little bit more in depth. A magnetic disk primarily consists of a rotating magnetic surface called a platter. That's basically a hard drive, solid state versus hard drive. So an SSD is a type of mass storage device similar to a hard drive disk. I know we kind of went over this earlier, but I want to go over it a little bit more in depth. It supports reading and writing data and maintains stored data in a permanent state, even without power. SSDs are rapidly becoming the system drive of choice for laptops and convertible computers, as well as for performance-oriented desktop computers and servers. SSDs are faster as well as more resilient to damage than a hard drive. The only upside to having a hard drive, honestly, is the fact that you're saving money based on gigabytes per storage. But SSDs are faster and they are not affected by shock, so you don't have to be as cognizant of having materials around that could shock your computer and potentially wipe your hard drive. Let's hop into some more memory reliability protection mechanisms. And here we have error logging. So memory reliability protection may also include error logging mechanisms. These mechanisms record and store information about memory errors that occur, allowing system administrators or technicians to identify and troubleshoot potential issues. So logging is pretty much something that you turn on in your environment, and you want to have a centralized logging system. So each computer has its own event log, but you can consolidate all of that into a central logging system when you get into an organization where you have to manage thousands of computers. So that might look like an Atera desktop support system, where Atera offers remote desktop support capabilities, so you can remote into your client's device as well as manage the device and check out error logs and different things. So that's an example of a centralized error logging system, and you definitely want to keep that around just in case things happen and You can't necessarily put hands on the device, but you can, or the device is not powered on, and you want to take a look at like what has happened, within the past day, 2 days, 30 days, whatever. By implementing memory reliability protection mechanisms, computer systems can be enhanced, and overall reliability and stability of data storage. You'll reduce the risk of data corruption and improve the overall system performance. These protections are particularly important in critical systems such as servers or system handling sensitive data, where data integrity and system reliability are paramount. So basically, this is talking about when you're part of an organization and you have a job, and your job is to preserve the integrity of the system. Data is a big part of preserving that integrity, because without data, nobody can work. So you definitely want to implement something that is going to be cognizant of how you can protect data whenever you're a part of an organization or a corporation. That's going to be part of your job as a system administrator or as a system analyst. As a system analyst, this may look like backing up employee data to OneDrive, or backing up, whenever you're changing devices, backing up data on a hard drive and transferring it to another device, but keeping a backup of that data on that hard drive, just in case something was to go amiss or to go wrong with video editing. I strive to keep all of my data around. I'm a data hoarder. Like videos that I have that I've shot within the past 5 to 10 years, I try to keep a record of it. So I keep hard drives on hard drives and hard drives around my place that have data from years and years and years ago. But you always want to keep that data around, because you never know when you're going to need it. Now we're getting into different types of disk drives. If you can remember data, SATA, PATA, ATA, RATATA, ATA, we're going to go ahead and get into that. PATA is an acronym for Parallel Advanced Technology Attachment. It is an IDE standard for connecting storage devices like optical and hard drives to the motherboard. PATA is a term that generally refers to the cables and connections in line with this standard. PATA used to be known as ATA, and it only became Parallel ATA when the new SATA came into existence. SATA offers a higher transfer speed than PATA hard drives. That is because PATA only transfers data in megabytes per second, while SATA interfaces allow you to transfer data in gigabytes per second. Remember, megabytes, gigabytes. This is a considerable distinction from PATA. This increased speed is useful when you need to transfer large documents. Also, if you enjoy playing games, the high transfer speed from SATA ensures a smooth and seamless gaming session. So for all you gamers, you want to make sure that you have a SATA disk drive. This is just a little bit more about the history and the technical differences. Basically, all you have to know is that the technical differences are SATA is the newer form and it works faster. So just remember, gigabytes per second as opposed to megabytes per second. It's just another form of a storage device. These interfaces are available within the actual disk itself. So when we talk about SATA and ATA and PATA, these are components that are actually housed within your hard drive. So it is its own physical component. SCSI, a small computer system interface, is a smart bus. Remember, when we talk about buses, when you say bus, think highway. It's basically a way that you transfer data. It's basically like a highway for transferring data. It's a smart bus controlled with a microprocessor that allows you to add up to 15 peripheral devices to the computer. These devices can include hard drives, scanners, printers, and other peripherals. So when you think interface, think of connection. That's something that you're going to connect to. So a small computer system interface is just a small connection that has a bus, basically, that transfers data. So it depends on what data it can be. It can be any type of data over this device, and it allows you to connect to drives, scanners, and printers. Optical drives. Now, optical drives are your compact discs, your DVDs, your Blu-rays, and an optical drive is a type of computer disk drive that reads and writes data from optical discs through laser beaming technology. Optical drives are fading from standard system configurations. We all know, when's the last time somebody's like, hey, let's go to Redbox and get a DVD? Like, nobody does that anymore. Most people use streaming services. but you definitely should be aware of what an optical drive is and what the common use cases for it are, which are compact disc, digital video, DVDs, and standard Blu-ray discs. So if you want to know a little bit more about that, I'll provide some links, but just understand that an optical drive is a CD or a DVD. External hard drives fall into two categories that we pretty much already covered. The HDD, which is the hard disk, and the solid state drives. Hard disks are mechanical devices that read and write data similar to how a turntable plays a vinyl record. So we already covered that. We talked about hard disks in the sense of being inside of a PC as the main storage device, but you can also have a hard drive and a solid state drive as external hard drives that you can attach through USB or USB-C or whatever cable that you have, depending on whatever hard drive you have. Flash drives. A flash drive, everybody pretty much knows what a flash drive is. It can be called a thumb drive or a jump drive. A flash drive is a small, ultra-portable storage device, which unlike an optical drive or traditional hard drive, it has no moving parts. Flash drives connect to computers and other devices by a built-in USB Type A or USB-C plug, making an all-in-one combination USB device and cable. Flash drives are often referred to as pen drives, thumb drives, or jump drives. Backup storage is part of your reliability protection plan. In IT, one thing about technology that you need to know is that there will always be failures. It's man-made and man is imperfect. So everything that we make essentially is going to be imperfect. Ultimately, there is going to be failure. So to cover your ass as an IT professional, you should be constantly doing backups on your storage. You should be constantly doing backups. You should have a backup plan. You should know the backup plan. And you should make sure that it runs on a schedule. It just covers your ass. It just covers your ass. Cover your ass with backup storage. A system failure wipes out all your data. Corruption renders your data useless. An error leads to permanent deletion. Remember, data loss always sneaks up on you. Ain't that the truth? The only way to tackle data loss incidents is by putting a solid backup strategy in place. And you can use Veeam, which offers virtual machines. You can spin up different virtual machines and backup data from these virtual machines or to these virtual machines on virtual servers or on your own physical servers. So it just depends on what your preference is and what your organization's preference is. But definitely look into different ways to back up your data. Most companies today do backups on their data rather diligently, yet 1/3 of them experience problems with backup restoration. The dichotomy lies in the way a backup strategy is perceived. There are mainly 3 types of backup: full, differential, and incremental. And we'll go ahead and hop into those now. A full backup is the most complete type of backup where you clone all the selected data. This includes file folders, SaaS applications, hard drives, and more. The highlights of a full backup is the minimal time it requires to restore data. However, since as everything is backed up in one go, it takes longer to back up compared to other backup types. This is like waiting till the last day of your school project. You've been working on it all semester, but you never press save. You just left your device open, and now you want to save it to your computer. It's going to take a long time to save all that data at once, rather than saving it incrementally along the way in short spans or short spurts. The other common issue with running full backups is that it overloads storage space. So you don't know how much data you're actually backing up until you do have an idea, but it's very easy to overrun your storage capacity with data when you're doing it all in one sitting as opposed to like incrementally uploading the data. That's why most businesses tend to run a full backup and occasionally follow it up with differential or incremental backups. This reduces the burden on the storage space, increasing backup speed. Differential backup straddles the line between a full and an incremental backup. This type of backup involves backing up data that was created or changed since the last backup. To put it simply, a full backup is done initially, and then some subsequent backups are run to include all the changes made to the files and folders. Lets you restore data faster than a full backup since it requires only 2 backup components. an initial full backup, and the latest differential backup. This is how a differential backup works. Day 1, you schedule a full backup. Day 2, you schedule a differential backup. It will cover all the changes that took place between day 1 and day 2. So a differential backup is basically after you do a full backup, whenever you make changes, the differential backup is updating those changes. The last form of backup is an incremental backup. The first backup in an incremental backup is a full backup. As you can see the trend, most backups are a full backup first, followed by these other steps. The succeeding backups will only store changes that were made to the previous backup. Businesses have more flexibility in spinning these type of backups as often as they want, with only the most recent changes stored. So the big difference between an incremental backup and a differential backup is that in an incremental backup, you're updating the last backup that was saved. In a differential backup, you're updating all the changes for 1 and 2, if that makes sense. And you can see more links, more resources. RAID storage. RAID storage is a form of storage that basically good for redundancy. And redundancy is a term you're going to hear a lot in networking and in storage, because redundancy basically is if something fails, it will fail over to this next device that offers the same capability. So redundancy basically is if one thing fails, all the data from this one thing can be found on something else because it's redundant. There's 2 different copies of the same thing. So if this fails, I still have my data available on this. So definitely when you think of redundancy, think of backup. I have a backup for whatever fails in my organization, whether that be networking equipment or whether that be storage. RAID, or redundant array of independent disks, is a data storage virtualization technology that combines multiple physical disk drives into one or more logical units for data redundancy, performance improvement, or both. So basically you just get a bunch of disks together and you combine them for performance and for redundancy. It's a way of storing the same data in different places on multiple hard disks or solid state drives to protect data in the case of drive failure. A RAID system consists of 2 or more drives working in parallel. These can be hard disks but there is a trend to use SSD technology. RAID combines several independent and relatively small disks into single storage of a large size. RAID systems can be used with several interfaces, including SATA, SCSI, IDE, or Fiber Channel. Some systems use SATA disks that have a FireWire or SCSI interface for the host system. How RAID works. RAID works by placing data on multiple disks and allowing input-output operations to overlap in a balanced way, improving performance. Because various disks increase the mean time between failures, storing data redundantly also increases fault tolerance. So redundancy and performance. RAID arrays appear to the operating system as a single logical drive. RAID employs the technique of disk mirroring or disk striping. Disk mirroring will copy identical data onto more than one drive. Disk striping partitions help spread data over multiple disk drives. Each drive's storage space is divided into units ranging from 512 bytes up to several megabytes. The stripes of all the disks are interleaved and addressed in order. Disk mirroring and disk striping can also be combined in a RAID array. In a single user system where significant records are stored, the stripes are typically set up to be small 512 bytes so that a single record spans all the disks and can be accessed quickly by reading all the disks at the same time. In a multi-user system, better performances require a stripe wide enough to hold typical or maximum size record, allowing overlap disk input and output across drives. There are different levels of RAID. There are a lot of different levels of RAID, but for the CompTIA A+, there's only a couple that you need to know. RAID 0 is disk striping. With RAID level 0, the data is split across drives with no data redundancy. RAID level 0 improves read and write performance by writing to multiple drives at the same time. You need a minimum of 2 drives. So basically, you have drives linked together and they're downloading data at the same time. So there is no redundancy, there is no backup. If one drive fails, then you only have the data available on this drive. RAID 1, disk mirroring, duplexing. With disk mirroring, the data is written to both drives involved in the mirror in order to provide data redundancy. Windows 7 supports disk mirroring. Disk striping with parity, RAID 5 volume. The RAID 5 volumes, the data is written to multiple drives along with parity information that is used to help recover data if a single drive fails. So RAID 5 volume needs a minimum of 3 disks. RAID 10, mirror disk striping. RAID level 10 is also known as RAID 1 plus 0 because it is a disk striping while mirroring the data written in the stripe. So it's basically RAID 0 plus RAID 1, as we can see from the name. So just think 1 and 0 combined when you think of RAID 10. It offers redundancy as well as improved performance. We're wrapping up our storage devices, so we're going to hop onto local network storage devices, and this can be used, so a NAS or a network attached storage device, which is a server basically. It'll be like a little box with different drives inside of it. It can have solid state drives comprising it, or it can have hard disk comprising it. It just depends. There are two types of devices that allow for a single storage location on a network, which can make sharing files between devices easier and make data backup and restoration simpler. So network attached storage, your NAS, is basically a system where a storage device is connected to a network that allows storage retrieval and data from a centralized location or authorized network user and client. So basically a NAS is just a box with a bunch of different hard drives inside of it, and that box can be connected to a network, and whoever is connected to that network can access that data on that drive. That's why it's called a network drive, is because you can store things on a network in one folder. A file server is a computer attached to a network that provides a location for shared disk access. Storage of computer files such as text, images, sounds, and videos that can be accessed by workstations that are able to reach the computer that shares the access through a computer network. Current operating systems for PCs enable one computer to share files and folders with others. However, for faster performance, business networks use file servers. A file server contains one or more drives, is connected to a network, and is designed to transmit and receive files from multiple devices at the same time using 1 or more gigabyte Ethernet or 10 gigabyte Ethernet network adapters. Data centers often use multiple file servers. Cloud storage devices. Cloud storage, when you think of cloud storage, just think of a room full of file servers that people can access from all over the world. All the cloud is basically just a room or a building full of servers that are networked, so people can connect to those servers without having to be a part of the network. So cloud storage is a model of computer data storage in which the digital data is stored in logical pools. The physical storage spans multiple servers, sometimes in multiple locations, and the physical environment is typically owned and managed by a hosting company. These cloud storage providers are responsible for keeping the data available and accessible, and the physical environment protected and running. People and organizations buy or lease storage capacity from providers to store user, organization, or application data. As mobile computing devices, laptops, and convertible computers, smartphones, and tablets have become widespread, the need for storage that can be accessed anywhere has also grown. Cloud storage devices enable both personal and business users to access their information and apps anywhere an internet connection is available. Services such as Google Drive, Microsoft OneDrive, Apple, iCloud, Dropbox, Amazon Drive, and others offer subscriptions that provide access to specific amounts of cloud-based storage. So the advantages of having a cloud storage system is that you can access the information from anywhere without having to carry around a heavy hard drive or a million solid state drives or different storage cards. Everything can be accessed from the internet. Whoever is hosting that cloud service, you're using their hardware as opposed to using your own hardware to run applications and to buy or lease storage. So you're basically like renting storage. It's basically like if you have a storage space, like a public storage place, where you put your furniture and clothes and you store stuff. You have to pay a lease to them to be able to store your stuff. The same thing is true for cloud storage. So you're not storing furniture, you're storing files and data. And this data is paid for, access to this data is paid for by a subscription. So you'll see a lot of companies like Microsoft and Google and most other tech companies are moving in this direction. It's becoming more and more common. The subscription model offers more potential for revenue and profit. So you're going to see a lot more of that moving forward. If you want to take control of your own storage, you can store things locally with a NAS, with a network accessible storage, or with a file server. If you don't want to go that route and you want to kind of leave the headache to a third party, then go ahead and set yourself up with a cloud storage vendor and go ahead and get on Google Drive or Microsoft OneDrive or iCloud. Most people use cloud storage every day in their everyday lives with iCloud, so you should kind of be familiar with it, but I understand that cloud computing is a concept that goes over a lot of people's heads because it just sounds kind of foreign. We all know that we use it, but we don't necessarily know what it is. But hopefully this kind of cleared that up and gave you an idea of what cloud storage actually is and what it does. So these are your resources for day 2. I'm going to update a lot of these as well. So go ahead and dive into those and make sure that you're familiar with the different storage devices, expansion cards, as well as cooling mechanisms, because these are going to be things that are important coming up when you are looking to take the CompTIA A+ and studying for the CompTIA A+, because hardware is about, if I'm not mistaken, hardware is about 20% of what you need to know. So definitely dive into these things, utilize these resources, and get ready for next week. Until next time, like and subscribe.